Hello everyone. Here in this particular lecture we will discuss about the digital storage oscilloscope instrument, in short DSO. So in digital storage oscilloscope we can measure both the waveform and spectrum. Waveform is the if you have a signal, the amplitude versus the time period measurement, or amplitude versus time period graph, will give us the waveform, and the amplitude versus frequency will give us the spectrum. So in DSO, we can measure the amplitude of a signal, we can measure the time period, frequency, and many other advanced applications. So let us see here what is there in the internal block diagram of the DSO. Here is my input signal, which is the analog in nature. It is coming from the device, and this input signal I want to analyze. So this input signal should not be too weak or too strong. If it is too weak, then this input signal will be amplified by an amplified circuit, and then this signal will be given to the digitizer circuit. In the digitizer circuit, this signal will be sampled, quantized, and encoded. This sampling will be taken place following the Nyquist sampling theorem. That means sampling is a process when we are chopping the signal along the x-axis or time axis at equal time intervals. So this sampling should happen following the Nyquist sampling theorem, which states that sampling frequency should be greater than equals to twice of the maximum frequency of this analog input signal. So in this, according to this theorem, we need to sample the signals in the digitizer. If in case the sampling frequency is less than the twice of the maximum frequency of the input signal, in that case signals will overlap and we will get some distorted output. Now, once this analog signal is converted to the digital signal, the digitized data will be stored in the memory, because the computer requires the binary information for processing. That is why we need the digitized information. That is the main aim, to convert the analog signal to the digitized information. Then that digitized information, which is stored in the memory, it will be analyzed by an analyzer circuitry, which will process that digitized data, and it will try to find out some important parameter from the data, like amplitude, frequency, like that. So whether the digitized data will be able to calculate the important parameters like amplitude, frequency or not, so that will be analyzed or processed in that analyzer circuitry. Then that digitized signal will be converted back to the analog signal, which is called the waveform reconstruction. Because if I want to observe the visual representation of the signal on the screen, then I need to reconstruct the signal back to the analog signal. Okay, that is why, that is the purpose of this waveform reconstruction. Then CRT, which is called the cathode ray tube, it is the heart of this instrument. Okay, so in this CRT, in this screen, what happens? A high energetic electron beam, when it strikes on the phosphor screen, the screen is made up of the phosphor material. So when the high energetic electron beams strike on this phosphor screen, we can observe a spot or beam on the screen. Okay, so there is a vertical plate. In this instrument, we have the vertical deflection plate arrangement, which is driven by the input signal itself. Here we are converting the digitized signal to the analog signal, right? So this vertical plate, which is a system in this instrument, it is driven by the analog signal, and that spot, it will help to move the spot vertically. Okay, and we will be able to see the amplitude of the signal, because usually in the y-axis we measure the amplitude. Next, we can see from this amplified analog input signal, we are feeding that signal to the triggered circuit. This triggered circuit will decide from which exact part of this analog input signal we want to display on the screen. So that is decided by this triggered circuit. Next, this clock works as a timer. So all these converting to an amplified version, digitizing, then storing memory, all these operations, whether they are happening in sync or not, that will be taken care by the clock circuit. So these two signals are given to the time-based circuit. This time-based circuit will generate the sawtooth wave or ramp wave. As I told that this instrument is having some vertical deflection system which is driven by the analog input signal. Okay. Similarly, this system is also having the horizontal deflection plate. Okay, so these horizontal deflection plate, it is driven by the ramp or sawtooth signal that is getting generated from the time based circuit, and that ramp or sawtooth signal will help to move that beam or spot in the left to right direction. So as a result, we will be observing the signal in the x-axis. Okay, so this is how we can observe the waveform of a signal in the CRT screen.